Welcome to another exercise in the workbook Statistics. This time I'm going to talk about an exercise on the confidence intervals for means. So let's have a look at the exercise. For 10 students, the mark of the final thesis is summarized below. And we have here the information about the students. And our task, determine a 95% confidence interval for the actual average mark of the final thesis. Well, if we want to do this, the first thing we need in either case would be the arithmetic mean. So we're going to add up all our values, that's the first part here, and then divide them by the number of observations. Here we have 10 observations, so dividing by 10 gives us an average of 2.1. This we then can use in the next step because, as we've seen from the exercise text, we do not have any information about a variance, about any standard deviation. So we have to calculate the standard deviation on our own as well. And well, for this, we're going to need the arithmetic mean. So for the standard deviation, or rather in the first step for the variance, what we're going to do is for each value we have, so for the 1.7, 2.15 and so forth, we're always going to subtract the mean and then square the end result. So it's always this part minus the mean, value minus the mean, value minus the mean, to the power of 2, to the power of 2 and so forth. All of this added up and then divided by the number of observations minus 1. So here we already said we have 10 observations. So number of observations minus 1 would be divided by 9. This then gives us the corrected or the sample variance. Well, if we do all this, in the end we get to a value of 0.2288. So that's our variance. Well, but we do not need the variance, we need the standard deviation. So we're going to take the square root of this, which yields us a standard deviation of 0.4784. That's actually what we're going to need for our interval. And there's one final part we're going to need. Well, since the variance is unknown, since we had to calculate the variance and the standard deviation here, we're going to work with the t-distribution version of the confidence intervals. So we also need the corresponding quantile of the t-distribution. So how do we get this? Well, we always determine this one as with t n minus 1 and then 1 minus 1/2 alpha. Well, n we know is 10, so here we're looking for 9. And we also have a 95% confidence interval, so our error, margin of error, is 5%. So we would enter an alpha of 5% or of 0.05 here, which then gives us here a value of 0.975. It's not 0.95 because it's a two-sided interval. For one-sided, it would actually be 95%. Here it's two-sided, so the error is distributed evenly on the left and the right. So we have 2.5% on the left error, 2.5% on the right side. Well, we look up this quantile and in the table we get a value of 2.2622. Then we have all the information we need. We have the arithmetic mean, we have the standard deviation, and we have the quantile of the t-distribution. And well, of course, the number of observations as well. Because if we summarize those ones and take a look at the formula we're going to use here, we see we need 4 values and we have all of them listed up here. So we simply have to take these values, plug them into this formula for the confidence interval, and we will get as a final result 1.7578 and 2.4422. So on average, or the real average for the mark of a thesis will be somewhere between these two values. And that's a relatively broad interval regarding a mean, but then again, we only have 10 observations. So it's a very small sample. And for this sample size, that's actually a decent result. Well, that's everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.